Well, welcome to week 7 of CS394R and a discussion into continuous random variables. So as you may recall, we've spent the last 2 weeks talking about discrete random variables, and we closed out last week with some examples of how to apply discrete random variables. In these next 2 weeks, we're going to follow very much the same trajectory for continuous random variables. So we'll spend this week looking at a lot of the fundamentals, the properties, the applications, the tools associated with continuous random variables. Then next week, we'll come back and look at some of the real life examples associated with continuous random variables. How do we actually apply this to real probabilistic systems? So continuous random variables are really just a way to say, rather than have a discrete number of outcomes, some subset, maybe 1, 2, 3, and 4, are the only outcomes that we can have for our random variable, now we can get down to real world values that have continuous sample spaces that can be 1.123456789, whatever value you want to assign to it. It can hold any value that is continuous. So to do this, we'll need to introduce some new toolkits, some new tools that we can use to help process and understand these continuous random variables. And again, that's what we'll spend these next 2 weeks going over, is the tools that we can use in order to best process and manipulate these continuous random variables so that we can use them, again, to solve probabilistic systems. So in this first lecture, we're going to first introduce the concept of the probability density function, or PDF. And this is basically the continuous analog or the continuous equivalent to the probability mass function, or PMF, that we've discussed over the last couple of weeks. Then we're going to look at some specific PDFs, so the uniform and then a piecewise PDF. We'll then look at the mean and variance of these PDFs, these probability density functions, but they're going to be applied to continuous random variables. And then after that, we'll take a little bit of a detour back over to the MIT lectures and talk about the mean and variance of the continuous uniform random variable, exponential random variables, and then a random variable that most of us are probably familiar with already, but that is a normal or Gaussian random variable, which is a form of continuous random variable. So with that, we'll go ahead and kick right off into our first section, the probability density function.